Forget frequently asked questions, common sense, common knowledge, or Google. How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5% go above and beyond and become very good at what they do. But only 0.1% are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in fields such as sleep science, cancer, stem cells, ketogenic diets, and more. Get ready. Here come the geniuses. This is the Finding Genius Podcast with Richard Jacobs.
Hello, this is Richard Jacobs with the Future Tech and Finding Genius podcast series. I have Humphrey Bacchus, co-founder of a company called Invivo Diagnostics. They provide diagnostic testing services that analyze the microbiome, host immune status, and genomic data. And we're going to be talking about the work that he does there and other work as well. So, Humphrey, thanks for coming.
Well, thank you. Thank you for having me on.
Yeah. So, what caused you to go into the field that looks at microbiome and these kind of issues? Like, is there a personal interest in your trying different areas in science?
It was kind of a bit of a long-winded approach actually for me. So I have an unusual background. My original undergraduate degree was in philosophy and linguistics, and then I actually ended up doing a secondary degree in physical therapy. And when I was working in kind of physical rehab and neuro rehabilitation, I quickly realized that there were kind of patterns happening within patients that I couldn't work with on a purely physical level. So I embarked on a postgrad master's program in clinical nutrition, and that's where I started to get really interested in the microbiome. I was in clinical practice for a decade or so, and when I joined Invivo, we were a pretty small startup company just starting to work in the microbiome field, a decade ago, really taking other people's microbiome tests from around the world, kind of in the early days, I guess, really of kind of PCR and kind of commercialization of that in the microbiome space and taking that forward. And it's really been a decade of learning and talking and translational science. For me, always being a clinician, I've always been interested in that kind of translational role, really, from the science into what we can tease out of it and how we can apply it in clinical practice. I think that's always been the core of kind of what's interested me, and outside of that, the wider aspects of kind of thinking about the microbiome internally and the health of the microbiome is kind of a direct reflection of kind of how we look after the external environment as well. The microbes are one part of us, and for me, there's a lot of interest in the kind of the wider ecosystems and how we support ourselves. And when you look globally at the moment, the challenges in the soil or challenges in kind of weather systems, you can kind of like almost draw a direct correlation to the challenges that we have within our microbial ecosystems internally, and that's certainly kind of led me and my team to kind of dive really deep into microbiome science.
So what's the focus of Invivo's work right now?
So if we were to kind of like sum it up in a mission statement, our mission is restoring human health and ecology. At Invivo, we see the work that we do as indivisible from the impact that it has on the wider community, the wider ecological community. If we nurture and nourish our own internal human ecosystems through understanding the role that these microbes have to play in host immunity, in health and disease, in pathogenesis of disease, and if we can kind of like nurture these microbes rather than kind of like treating them as as invaders the whole time, then we also have an opportunity to look after the wider environment in which we live. So our focus is really around trying to help patients. They're the end users of our services through their clinicians to understand more about the relationships that their bodies have with these microbes specifically in the development of disease.
So again, specifically, are there any conditions that you're targeting, or is it more of a prebiotic, probiotic type thing, or what? What would be some commercial applications?
Of course. So at the laboratory in Bristol, which we have a division of the company. So Invivo Healthcare is the kind of the holding company. It's kind of the clinical commercial arm. We do all the education, the training with the clinicians. We have about 4,500 clinicians, mainly throughout Europe, use our services. So we kind of provide the laboratory diagnostics, but the lab itself is a division. It's a separately run company, independent scientific advisory board. Management structure, which is based out of Bristol, and we focus on 3 microbiomes currently at the moment. So the vaginal microbiome, the oral microbiome, which I know that you've chatted to one of my colleagues about, and the gastrointestinal microbiome. And I think we're inspired really. I mean, there's been so much focus on the gastrointestinal microbiome and the impact on health and disease, but very little commercial work has been done in the application of these other microbiomes that have a huge role to play in health and disease. I mean, if you take, the role of the vaginal microbiome and its kind of niche ecosystem, even for us, in the panels that we've developed, even helping clinicians, with patients that have got long-standing recurrent, infections or what appear to be, for example, candidiasis, and they have repeat treatments. For us, it's the ability to look at the microbes and the pattern and the context, and to be able to help clinicians realize that actually it's not a picture of candidiasis, it's a picture of bacterial vaginosis, or to see the proliferation of specific lactobacilli species and realize that it's cytolytic vaginosis. So it's kind of it's a tool really to the tools to kind of differentiate and help clinicians guide. I wonder whether the microbiome will ever be a diagnostic tool in itself, because it doesn't, exist separately from us. This kind of bidirectional pull, the microbes driving the disease or the disease driving the microbes. It's difficult to kind of tease it out exactly. And I guess from my perspective, the more we dive deeper into the science, sometimes I feel like I know less in some ways today than I knew yesterday in terms of the complexities. That's just around the vaginal microbiome. And if we dive into the oral microbiome, go ahead.
A question here. Are you looking for the absence or the prevalence of species? Are you looking at the metabolomic profile? Or, from speaking to people, there's many different ways to look at it. And it sounds like just looking at what species are there or not isn't very helpful because of the redundancy of a species to be able to do what needs to be done in a given niche.
Yeah, of course. I think one of the things that we always do, so for example, some of the kind of metabolomics and is obviously, kind of a lot of work being done on kind of, the host, and that's quite strong when you look at the kind of the bacterial aspects, kind of its emerging science. For us, all the work that we do, we measure host markers, and this host microbiome response is just really, really important. So for example, you can't take, and I completely agree with what you're saying, it's very difficult to isolate specific strains of bacteria and and immediately tie them to a disease state. For example, you need to kind of pull together multiple pieces of information. So from us as a lab, we're very interested in this kind of host immune response. So for example, if you take the vaginal microbiome, so we measure the pH, which is a really core indicator of kind of a lactobacilli rich environment. Which is really key for vaginal health. So we measure the pH, then we look at interleukin-1 beta, so it's an inflammatory cytokine, which is really key. So that kind of gives us these are kind of host markers. They're independent of what's happening in the kind of the microbiome. Then we're looking at kind of key keystone species, lactobacilli rich, and then we obviously start looking at pathogens or kind of pathobionts. And it's not the presence of these microbes by themselves which indicate a pattern. It's again, it's what is the host immune system doing? So, for example, in the gastrointestinal microbiome, you might want to be looking at, a marker of innate immunity like beta defensin 2, for example, secretory IgA, 2 primary innate immune responses, which are going to indicate, to the clinician, basically, how is this individual responding to the presence of certain microbial patterns. And I think this is really, really key, that this is the kind of the main thing, the microbes don't, exist in themselves like causing disease. We always need to be coming back to the host markers. And I think for us right now, that's where we're spending most time kind of focusing is really trying to get clinicians to understand about, context and pattern it's really, really important. The idea of just being able to kind of like, target specific microbes, as you said, and just like, say this causes disease or this causes, health is very challenging.
Well, I remember years ago, I did, my gut bacteria sample with Ubiome, and I got back a list of a bunch of species and zero information. I was like, okay, well, that tells me nothing.
Yeah.
And then I've done them more recently, and it's a little bit better, but not too much better. That this may be indicated in this or that. But
I think
it seems it seems like people would need to sample themselves multiple times over, let's say, a year, and get a baseline for themselves, not only in terms of species prevalence, but what's there when they're in a healthy state. And then when something happens, they get sick, they'd have a reference at least for themselves on what to do, what was normal for them.
Yeah, I think you're right. I think there's longitudinal mapping, and there's not many studies out there that have been done. That's something that we've got our eye on in terms of, frequent sampling over long periods of time of individuals. Certainly mapping disease progression, that's going to be incredibly important as well. Taking kind of, even if you say, take a patient with a familial history of colorectal cancer, for example, and then, literally almost like mapping them every 3 months over a 20, 30, 40 year period, it's going to be really interesting to kind of see shifts and changes. But you only have to look at the influence of diet, whether or not you're choosing a ketogenic diet, a Mediterranean diet, high carbohydrate diet, FODMAP diet, to see kind of quite profound changes to microbial diversity. So that's obviously one thing that's pretty difficult to control for. And some of these diets might be wanted to be used to have specific outcomes, which is important. But I think if we go even further back into the science and the technology, I think that a lot of the reason why we see even such massive variations between data that's being produced in a kind of next-gen sequencing or in metagenomic sequencing, which is not what we do. We're doing a kind of like a targeted kind of RT-qPCR approach, so kind of like more limited data sets in combination with host biomarkers. So that's kind of our approach, basically, is that, when you're doing the kind of the NGS work, is a lot of it's down to, of course, you got to look at sample prep, extraction, temperature, storage, making sure that those are all consistent, between like different people that are testing. And then you might use, different platforms, so PacBio or Illumina. And then you might use the same, different libraries or the same libraries. But then the work is down to the pipeline. It's the bioinformatics. What do you exclude? What do you not exclude? How do you basically work out what's noise, what's not? And so you see widely varying data sets coming out. And then the challenge is, well, what do you do with it? As you've just said, I mean, it's a big challenge unless, and I think that it does require, clinicians to really be well-versed, well-read, well-supported to start kind of teasing out important information based on clinical history, based on clinical, data of the patient in front of them, to be able to actually make something of the data. Otherwise, it is just it's a data dump, and it is really, really challenging. And I sometimes worry about the forums that I sometimes see of, I guess, ill, sometimes desperate patients basically being able to kind of do some testing, and then they say, oh, what do I do? I've got really high levels of Citrobacter frundi or Pseudomonas aeruginosa, and then they basically, searching through the internet, searching PubMed, find a single murine study on, specific botanical to kind of decrease, this, and then kind of assume if they just do that repeatedly, that basically somehow, their health is going to get better. And it's a kind of reductionist model, that kind of like, without kind of understanding a dynamic complexity that I suppose worries me most in the kind of of this science kind of being in the public domain.
Well, I mean, what would you imagine are the important factors to look at within someone's microbiome? Let's say, vaginally or in their intestines. I mean,
well, as I said, I think
one way I think about it, like I don't know if this is wrong. In one way, I think it's like a job center for microbes. In my gut, there's jobs to be done. There's things to be produced and consumed, and et cetera. So the microbes that show up there, like other microbes can do their job too, or that particular job. That's why there's redundancy. But I mean, like, how do you look at it? What's helpful for you to give a clearer picture of what's actually going on?
I think we always start with the host markers. So whenever we report, that's really important for us. So the first thing you see is kind of like, how is that, let's not focus immediately on the microbes, let's focus on the kind of the host response. So if you look at the vaginal microbiome test with us, first marker, pH, basically, simple, basically, it's saying, kind of how acidic the environment is. We know that's kind of one of the kind of key predictors. Patient history, of course, you can't look at a result without hearing someone's history and how they're presenting. It's complete, it's a unique, pattern. You've got, that's the end of the day. Patient is not a test result. An individual is not a test result. It's always context and pattern dependent. Then we look at things like immune, like inflammation markers. So on the vaginal microbiome panel, we look at interleukin-1 beta. Then on the GI, as I said, we look at host innate immune markers. So, are there any elevations of calprotectin? Digestive function, digestive enzymes, pancreatic elastase. That kind of almost gives you the kind of the soup in which the bacteria are swimming. What is the kind of the foundational kind of health of the host in terms of gastrointestinal function, inflammation, innate immune system, because that's what the microbes are communicating with. They're constantly, there's this kind of host immune gut interface, and so that's from our perspective, the role of the kind of keystone species or the commensal bacteria, kind of short chain fatty acid producers, or those that regulate immune function or digesting certain kind of starches and fibers. So you kind of start top level and you work your way down, rather than kind of working from pathogens up. And I think that's kind of how we see the data. Start with the kind of foundational aspects. Look at the host, work your way down, basically look at, the kind of foundational species. So in the vaginal microbiome, you're looking at, specifically 4 predominant lactobacilli species, the different kind of community state types, which is still a kind of like a working theory, but looking at the kind of the dominance of certain species, for example, but you have to understand the pattern, for example. So in cytolytic vaginosis, for example, yes, dominance of lactobacilli is really, really good, but too much is bad. And so it's a balance. You talk about like jobs to be done, but then too many jobs can be done. So, things can swing the other way.
What about the saying that something's a pathogen? Like in C. difficile, like in the gut, it seems to always be present, at least in small amounts. But when it becomes predominant, now it's a pathogen. But is anything a pathogen? Or are there things that are just always there, just in low predominance, and when the balance gets out and they rise, then now they're suddenly a pathogen?
I think it's very difficult to see, pattern. I come back to, as I said, I come from a practicing clinician background, and not from a kind of allopathic medical background, working kind of more kind of physical medicine realm. But when I look at, I speak to all our, scientific advisory board and our lab director and, our medical team. And I think, in most cases, pathogenicity is a contextual state. So, what makes one microbe doesn't always make one, the same, like if you take one microbe or the presence of C. diff toxins, for example, again, you've got to go back and look at how the host is responding. If you see, for example, elevations of, cancer marker CA125, for example, something like that, you're immediately saying that someone's got cancer. No, you have to investigate, you have to kind of see it, for example. So I think it's, there's, we're diving an awful lot deeper into realizing that, as you said, like just the presence of something. I think that's where we have to be very careful with the way that we report on microbes, particularly in the public domain, because I think kind of people can then worry without having the contextual state or, the horrors of Google, of just being, like any, people type in basically, any microbe that they find kind of elevated without understanding the contextual state. And I guess that's for us again, where you start looking at, if you just start looking at microbiome data on its own, out of the context of both presentation and some other kind of confirmatory host markers, like immune response, like inflammation, then it doesn't put context to what's happening with the microbes. So I kind of agree with, sort of concur with your kind of question. I think it's a challenge, There are some microbes, some pathogens, for example, in most cases, in most individuals, there will be pathogenicity, but not in everyone. That's a challenge at the end of the day. That's why, just doing kind of blanket screens and saying, okay, right, well, we can see this microbe, I don't know, let's say you see small amounts of Fusobacterium nucleatum, for example. And then you go, okay, right, well, there's some research that says, the presence of that in the gut basically is, strongly correlated to development of colorectal cancer. That patient has colorectal cancer. We just can't do that.
Have you seen interactions of, or let's say our gut bacteria or any of our bacteria with our host cells, like bacteria to cell direct somehow contact, or is it just that, our cells will release things externally and then the bacteria will pick them up and vice versa? Like, how intimate do you know is the contact between our constituent bacteria and our cells?
I mean, there's a myriad of different ways in terms of bacteria communicating with ourselves and our immune system, and it's constantly communicating. It's interesting. So, one of our scientific advisory board, and we were chatting not so long ago, and someone called Dr. Javier Ochoa Reperez from Eastern Washington State University, and he was saying if I was to sum up my last 15 years in microbiome research, it would be interleukin 10. So that's what it's a signaling, interleukin, host immune response marker. And it was interesting, for me to hear, because again, it's this kind of host immune interaction, signaling, and it's bidirectional. So our cells are communicating back to the microbiome, and the microbiome is directing to the cells, signaling, hey, this is what's going on in the outside world. This is what I'm exposed to. This is how I need to respond. So it's kind of infinite almost in its complexity. And I just don't think we've fathomed, and I wonder where it's going really. I mean, I find it highly exciting, but also I think that the kind of the depth and the complexity, you talk about some of the kind of the early stuff is kind of where are we going with metabolomics and things like that. I mean, I think is definitely a kind of a future frontier. But again, just from taking it out of research, I think always the challenge is how do you apply it in clinical practice? And that for us as a lab, is, working with clinicians is, research often doesn't get translated, or takes an awfully long time to get translated. And often people are looking for singular cause and effect rather than complex patterns. And if you're looking for complex patterns, how does that get digested? I don't know if it's I'm pretty sure it's the same in the USA right now, but we have a political system which is pretty swung on just kind of the left and the right, and everything kind of gets brought down to kind of 3-word slogans, and no one seems to kind of be celebrating kind of inherent complexity, and the multitudes of different ways to kind of think about things. People kind of either want it to be one way or the other. And that's a real challenge, because I think that's clinicians want fast answers. People get information overwhelmed. So how do you digest this really complex information and, work to kind of apply it in clinical practice?
I mean, chasing individual compounds and pathways and all that. What about the theory? Is anyone working, or is there any funding for the underlying theory of what's going on?
Yeah, I mean, it's when you look at, well, not really. I mean, if you look at the microbiome space and you look where the funding is right now, the majority of the funding is in therapeutics. Basically, it's still kind of in the hope that the microbiome is one of the next frontiers in the pharmaceutical industry. But again, targeting is kind of almost like a singular cause and effect, either kind of modulating the microbiome or modulating an immune response for a specific disease, for example. So again, still trying to develop a microbe basically, or phage or something like that that's going to be able to treat a specific condition. So it's still kind of going down that. It's not really thinking about ecosystems or systems biology approach. It's not, you look at allopathic medicine. Most people say you can go and see the cardiologist, you can see the neurologist, you can see the gastroenterologist, and it's the same. This is that same symptom. It's the same thing that's happened with the microbiome. I mean, there's been so much focus on the gastrointestinal microbiome, but not so much on the oral microbiome or the vaginal microbiome. I mean, again, I know someone who runs a research group at the Bristol University in the oral microbiome and dentistry department, and looking at signaling between the oral cavity and the vaginal microbiome of Candida albicans species. So again, signaling microbes signaling to each other in different spaces, vaginal, different microbiomes in the body. But we're kind of still focused on this kind of, what happens in the mouth stays in the mouth, what happens in the, gut stays in the gut, you know what I mean? When we're moving out of that, of course we are. But we're still kind of looking for that, singular cause and effect. And I guess it's, we're still kind of like chasing that, because the complexity perhaps is just completely overwhelming. And I think, you do need to kind of not overwhelm people. And I guess that's what, we're trying to, maybe steer a middle path in terms of how we work with our clinicians, how we kind of educate them, how we kind of pull data. We neither kind of want to simplify it down to kind of wellness or ill health, and nor scare people, with complexity.
So what are the particular interventions you're looking to help create or shed light on, let's say with the vaginal microbiome, and then the intestinal, and then the oral? What are you focused in on as a company?
So, I think it's, kind of really, like a challenge, as I said, sometimes to kind of think about, different ways and different resources, so again, fundamentally, we're kind of as a company moving, or trying to basically work towards, really helping people to kind of think, move away from that kind of pill for an ill thing, and again, a huge amount of it. Let's start talking about the vaginal microbiome. There are huge amounts of just general ecological considerations, for example. So, frequent use of kind of vaginal perfume sprays and douches need to be avoided. They can prevent irritation. They can alter the pH. Smoking alters the pH of the vaginal microbiome, which is then going to allow, kind of like decrease in lactobacilli. It's going to allow increase the prevalence of, potential kind of pathobionts. So you can absolutely, like the biggest, like anything, we'll say, coin an American phrase. I used to, live and work in the US, the biggest, bang for your buck is going to be the kind of the things that you do every single day, the kind of lifestyle factors, for sure. You need to be looking at hormone balance, for example. You're going to make sure you're not getting like lots of kind of like, fecal vaginal contamination, for example. That's going to be really important. Stress has a huge role to play on microbial balance and immune function. So you kind of start with those things, and then you start kind of like, and look at the labs, and look at the presentation. And then you start looking at products, for example, and that might be used intravaginally. And then you've obviously got the oral route, and then you've got clinicians, working with kind of like probiotic pessaries or intravaginal applications of probiotics of specific species, for example, that are like whether it's Crispatus or Gasseriae, those types of interventions, or specific. There's a lot of work going on in specific strains and probiotics to kind of help, maybe not treat urinary tract infections, but kind of prevent post-antibiotic use, kind of recurrent urinary tract infections by kind of inhibiting biofilms and E. coli growth. So I think there's definitely a role to play, for example, and absolutely we're invested in that, helping clinicians kind of like, guide themselves towards kind of like, therapeutic applications. But we're very much got this kind of like wider ecosystem in mind, that you're not, this idea that, okay, right, I've got IBS. Okay, well, if I just take a probiotic, I'm going to, somehow make myself better. I mean, that's just flagrantly, just completely untrue. Maybe in a percentage, but what else are you doing, if that makes sense? Are you chewing your food properly? Are you sleeping properly? Are you making sure you got like nice fasting in between meals? You got to cover these kind of like big ground and bases, and that's where it comes in. And I kind of talk also about, when you're doing the testing, doing the diagnostics, it's like, let's look at some like key host markers, pH, interleukin-1 beta, key lactobacilli species, and let's put that in context with like the lifestyle and the environment, and then you kind of start to build up a picture. So I think that's, and of course, there's the role, for example, for things like BV, you've got common pharmaceuticals, metronidazole, things like that, or intravaginal applications again. But then, do you just do that and then just go back to square one, for example, or you do look at the underlying causes? For example, why is someone having repeat bacterial vaginosis? What else is kind of going on? It didn't just suddenly appear from nowhere. And I think that's kind of where we come in, is we're really trying to kind of empower or help clinicians empower their patients to kind of understand that their body is this complex ecosystem that needs to be nourished. And there's a wonderful Professor Martin Blazer, I think from NYU, who says we need to treat our bodies more like gardens and less like battlefields. And I kind of think that sums it up, really. I think, we often, see the body as something that just needs to be treated almost like a machine, that something needs to be treated rather than something that needs to be nurtured. I think that's, absolutely the essence of kind of where we are, both at Invivo Healthcare and our lab, Philo Bioscience, and all the work that we do within the microbiome at the laboratory.
So what do you think there's going to be clarity on, or maybe a short-term breakthrough in the next year or so with your work in particular? Or is it going to be much longer term?
I think it's going to be much longer term. For us, we're in development of, we've started, we want to do some work in, or we're already doing some kind of some work on the urinary microbiome, so that, we can start to kind of see, pitch and kind of research projects between the vagina and urinary, particularly recurrent urinary tract infections. I think, there's it's really important to kind of understand which specific microbes are involved, and sometimes there's some kind of more unusual ones involved. And then when it comes to the vaginal microbiome and fertility, infertility, recurrent miscarriage, this area, IVF treatment outcomes, this is a huge area of interest for us, and we're seeing some really great data, some really great interventions, and some kind of success stories from clinicians specifically working in the kind of female fertility space. I think this really excites us as a company. Again, it's a kind of an area that hasn't really been explored massively. And then also kind of coupling into that as well, and this has been led by some of our scientific advisory board team and this won't be commercially, but certainly from a research perspective, kind of starting to look at some dynamics of the semen microbiome and the role that has to play potentially. There's a dance between, obviously the semen has a huge, interaction with the vaginal microbiome. So obviously we're starting to, look at those patterns of basically what happens between partners, potentially in kind of cases of infertility or recurrent miscarriage, for example. There's obviously an interaction there that happens all the time. So we're definitely kind of looking at, the oral microbiome and the gut microbiome. These kind of dynamic interactions between different microbiomes is really where, and then kind of pulling that data together into test kits to give to clinicians and to make that information actionable, certainly on kind of a multitude of different levels, whether it's understanding, potential drivers in, disease, particularly like chronic disease, or whether it's kind of optimizing health basically to, as you said, pre-pregnancy to look at optimizing the vaginal microbiome to reduce the risk of, preterm birth, for example. And I think that's something that, we're certainly looking at the data and trying to work with clinicians to kind of, clarify from our data and from our tests and get that into clinical practice more readily.
Okay. Well, very good. So Humphrey, what's the best way for people to find out more about Invivo?
So the best way is to go to our website. So it's www.invivo, healthcare.com. So that's the kind of the commercial arm where we deal with clinicians and patients in terms of selling all our kind of services. And then if anyone's interested specifically in the microbiome laboratory that we have based out of Bristol, it's Philo, so PHYLO, philobioscience.com. And there you can read more about the work we do, our scientific advisory board, and some of the research projects that we have going on.
Well, very good. Well, Humphrey, thank you for coming. I appreciate it.
Thank you. Thank you for your time. Really enjoyed it. Have a lovely day.
Forget frequently asked questions, common sense, common knowledge, or Google. How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5% go above and beyond and become very good at what they do. But only 0.1% are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in fields such as sleep science, cancer, stem cells, ketogenic diets, and more. Get ready. Here come the geniuses. This is the Finding Genius Podcast with Richard Jacobs.